in the desert of Arizona was launched a project, Biosphere 2. Biosphere 2 was a huge hermetic greenhouse, and it was made to simulate an autosufficient spatial base on Mars. However, it turned out to be one of the worst scientific fiasco. And the original project was abandoned after 2 years because oxygen was dropping and CO2 was rising. Now you may wonder, what is the relationship between Biosphere 2 and my PhD project at CIFOR? Well, the main mistake they made at Biosphere 2 was to bring peat soil into the greenhouse and start to farm on it. Peat is stable when it's saturated with water, but it decomposes quickly when it's drained. And this was the reason why in Biosphere 2, oxygen was dropping and CO2 was rising. Worldwide, there is more than 27 million hectares of tropical peatland. And transforming this tropical peatland into oil palm plantation, we might be doing a similar mistake as the mistake that was made in Biosphere 2. So the title of my presentation today is Peat Swamp Forest Conversion into Oil Palm Plantation, the Effect on Soil Carbon Dynamic. I'm Pierre Comeau, and I'm working under the direct supervision of Crystal, and Professor Lou is also my supervisor. So the two main questions behind today's seminar is the conversion of intact peat swamp forest into oil palm plantation accelerating peat decomposition? And is the conversion of intact peat swamp forest into oil palm plantation increasing heterotrophic CO2 emission? Heterotrophic CO2 emission being the emission of CO2 from soil microorganisms and soil biota, excluding root respiration. And if the answer of this question is yes, will this CO2 emission on peat oil palm plantation remain constant until all the carbon has been respirated? Or will the soil system reach a new equilibrium at some point? The two objectives of the presentation today is to assess the heterotrophic respiration of the peat under intact peat swamp forest, logget forest, and 7-year-old oil palm plantation, and to evaluate the characteristic of the peat under the same tree land use. The plots are exactly the same as the Jody plot, and the chambers are also mainly the same as Jody plot. So the study site, as Jody already explained it, is in the district of Jambi. We have three different land use: intact peat swamp forest at Burbank National Park, a drained and partially logget forest, and a 7-year-old oil palm plantation. The drained forest and logget forest is an intermediate point between the intact forest and 7-year-old oil palm plantation. So previously, PhD candidate Jenny Farmer estimated the total amount per hectare of carbon in the same tree land use, and she didn't find significant difference between land use. But in her study, she was taking into account only the whole carbon, but in fact, in the peat, the carbon is in different compartments, and each compartment will react differently to this composition, and each compartment of the carbon in the peat has a different dynamic. PhD candidate Farmer also evaluated the CO2 emissions from the same land use, and she found higher CO2 emissions on the logget forest and oil palm plantation than the intact forest, but his data was not taken for a full year-round measurement, and she didn't make a systematic separation of the heterotrophic respiration and autotrophic respiration. So to separate the autotrophic and heterotrophic respiration, and each land use, trench were made, 10 trench per land use. The trench were until 1 meter deep and 2 meter per 2 meter. And these were, again, to partitionate autotrophic and heterotrophic component. Here today I will present the result of the heterotrophic respiration. Then the CO2 was measured monthly, is being measured monthly with an IRGA and EGM. And here I'm presenting only the IRGA measurement, which have more measurement through the year. The period of measurement I'm presenting is from January to May 2012. Then every month when we are going to take measurement of CO2, we are estimating the soil temperature, the water table. PhD candidate Jody Artil is taking soil moisture. All that to model at the end the different factors effect of the environmental variable on CO2 emission. And litter fall is also assessed every month, and every 3 months I'm assessing the litter decomposition. Could you go back to the previous? Those are the size of the chambers that we were asking about. It's the same chambers to measure CO2 and nitrous oxide and methane. So on May 2012, on each land use, 3 soil pits were dug of 1 meter cube, and the total dry weight of large logs were determined. And as well, peat samples were collected every 10 centimeters until 1 centimeter deep. In the lab, in the CIFOR lab in Jambi, the sample for each 10 centimeter increment were separated into root, small logs, medium logs, and fine soil. Today I'm presenting the results of 20 and 100 centimeter results. And then with the fine soil samples were brought to the University of Saskatchewan in Canada for a density fractionation. The density fractionation consisted into an heavy fraction, a medium fraction, light fraction, and very light fraction. The fractionation was made with sodium iodate and distilled water. Here we can see that the density fractionation is really simple. Everything that is floating on the dense liquid consists of lighter material, and everything that is sinking is heavier material. This density fractionation does not alter the chemical component or the chemical structure of the organic matter. Then the fractionated sample were sent for % of nitrogen and % of carbon to the stable isotope facility and to the UFS cytochrome for diffraction analysis. With that, the outcome of this fractionation method is a sequence of lightly discomposed material to highly discomposed material. At the end, having the heavy fraction that is supposed to be basically composed of stable humus that is recalcitrant to further decomposition in time. So the first result I'm presenting is the big log in the soil until 1 meter deep at Burback, Logette Forest, and oil palm plantation. I didn't find differences between the Logette Forest and the oil palm plantation, but at Burback, there were more big log than those 2 other sites. No statistical testing were made yet. And this is in concordance to the assumption that on the Logette Forest and oil palm plantation, the peat decomposition is higher than on Burback, which is the intact soil forest. Now the second result graph is the small and medium log proportion at 2 different deep, at 20 centimeters and 100 centimeters deep. The brown color is the medium log, and the yellow color is the small log. We were expecting, or it was to be expected, that deeper in the profile, the decomposition is lower because the soil is waterlogged. So we would find more medium and small logs than at 20 centimeters, where there's more aerobic decomposition. This trend was found for Burback, but it wasn't found for the oil palm plantation and the Logette Forest. Comparing the different sites, on the 20 centimeters, Burback has more medium log than the Logette Forest. but not more medium log than the oil palm plantation. At the oil palm plantation, we are currently increasing the sample to be sure that this is a firm trend, or this is just due to random effect. On the 100 centimeters, we found more medium log at Burback than the logged forest and oil palm plantation. And between the oil palm plantation and logged forest, there were not much differences. And this, again, is in concordance to the assumption that at the logged forest and oil palm plantation, the decomposition of the peat is higher than on the intact peat swamp forest at Burback that has more big material. And here, the third result is the percentage of highly decomposed material, the percentage of heavy fraction at 20 centimeters deep and 100 centimeters deep. Again, if we are expecting more decomposition at 20 centimeters, because there's more aerobic respiration, we are expecting more decomposed material at 20 centimeters than 100 centimeters. This is much less what we are obtaining there, that 20 centimeters in average is higher in heavy fraction than 100 centimeters. And comparing the different sites, on the 20 centimeters, at Burback, there were less heavy fraction than logged forest and oil palm plantation. And on the 100 centimeters, at Burback, there were less heavy fraction than the oil palm and then the logged forest. And this pattern is maybe due to the root architecture in the soil, where in the logged forest, the roots are deeper, decomposing more material at deep, and at the oil palm root system is mainly close to the superficie. So the last result I'm presenting today is the heterotrophic carbon dioxide emissions among Burback, oil palm, and logged forest. And as it was found before, the intact peat swamp forest has lower emission of CO2 than the oil palm and logged forest. And I didn't find, or it seems that I didn't find significant difference between the oil palm and logged forest. And this is probably due that both sites were drained much less at the same time. So at both sites, the decomposition starts and is going at the same rhythm. So in conclusion, is the conversion of intact peat swamp forest into oil palm plantation accelerating peat decomposition? I believe that yes, because we found less big log and medium log at Burback than the other side, the oil palm plantation and logged forest. And is the transformation of peat swamp forest into oil palm plantation increasing CO2 emission? Well, my result shown that yes, at Burback there were less CO2 emission than at the oil palm and logged forest. And therefore, will this CO2 emission on peat oil palm plantation remain constant until all the sea has been respired? To find out about that, we have to take more measurement in time of the heavy fraction and the different fraction, and to see if the heavy fraction is increasing and the other fraction are decreasing about 5 to 10 years in the time. So we could expect that when all the small fractions are decomposed and all the material is in the heavy fraction, then the respiration will slow down at the oil palm plantation and logged forest. And finally, I would like to say thanks to CIFOR, the University of Aberdeen, the University of Saskatchewan, the Stable Isotope Facility. Thanks to all my supervisors. Thanks to all the staff in the Jambi Lab. And thanks to Rosita, my girlfriend, wife, and my baby. And thanks to all the people who closely or distantly helping me to realize this study. And those acknowledgements are pretty much the same to Jody.